All right. So here's the thing, right? I've personally woken up early today. I mean, late today at 10. There has been things that have kept me busy, which, consist of like life admin, including like laundry, lunch. But we can always make room for Leetcode. Okay? We can always. So that's why I am here today. That's why I'm here today. The there is like a lot of stuff that I want to do, right? One, this afternoon, this morning, I've been trying to figure out subject selection for next semester. I've decided that I might, instead of doing a research project, do software project. So I've had some time to think about that. I will say, let's see, so the software project, the research project, my consensus on that was just to go for the software project and do that semester 1 or semester 2. With the internship subject either semester 1 or semester 2. Now, I already made the software project part of my next semester. That's only if I don't find a fitting enough internship in semester 1 of this year. Because if I do, then the uncertainties go down for me when I try to, if I have to search for an internship subject in semester 2, I wouldn't need to do that because I'll have it in semester 1. So my consensus is just to go for the software project in semester 1, and then if an internship that meets the internship subject requirements comes around, we will use that and defer the software project subject to semester 2. Right, that's the consensus of that. So I'm done there. I have somewhat done this. Part of it's done. I'm just going to tick this off and just so career development notes, right? So read over and apply career development notes. This is notes that I took yesterday with my onboarding buddy, which helped me identify the weaknesses that I have in my current 4 weeks at my internship at Amazon. So that's stuff that I'm personally taking action on as soon as possible, as soon as I can. It's unfortunate that it has to be a weekend so that I can't apply this straight away, but I guess it gives me some time to think about how to apply these the right way. All right, so that's how it works. I need to book a haircut, I think. This is not going to happen, so we're just going to cancel this. cancel. Command K, I think that's K or something. Command K? Shift K? Oh. Scheduler development, we're going to cancel that. We're going to move Leetcode up and we're going to set up all my ZSH because what I see, I saw someone else using it who was also an intern who was, shout out to you, Yash. But he's convinced me to go with my ZSH. Okay. Batteries included. Cool. Plugins. Cool. The problem is already jump in, we're offended. Oh, we're not offended. I need to know just like okay, so there is only one way to install this. Let's do this. Okay. Sure. I just want to have a look at what the previous ZSH was. I mean, I'll just cat. .zsh d .pre. Right. But arguably, it's still a lot. Yeah, there is a lot. Okay. Arguably, lots will be changed. Kind of regretting this. Oops, sorry. Dot files. Manual install. Install problem. Skip aliases. Getting updates. Uninstalling. Now I'm convinced to. So there's a from what I understand, there is a file called omyzsh. Okay, the ZSHRC got overridden. Okay. Omyzsh is something that I want. Perhaps save, but also, I don't know. Let me ask. Okay. Yeah, alright, yeah. So it's like still pretty easy, I guess. What I will say is then, let's go to dot files. Just open up a new terminal. So we'll go to dot files. Config. So we have a config file. There was where was it? .omyzsh that we want to save as well. Perhaps. Just trying to think. Yeah, I think that makes sense. I think omyzsh needs to be saved, I think. Regardless then, maybe not. I mean, if it's not in config, is it really necessary? So, the one thing I will say though is I need to reapply dot. Okay. Cause conflicts, rights existing. Sure. So the linear mouse that we currently have isn't pointing to the correct linear mouse, which is kind of shit also. My understanding then is also the ZSHRC isn't. So a rights existing, since neither a link nor a directory, adopt not specified. So if it's adopt, let's see. So import existing files into the package target. Let me have a quick look at what adopt does. How do I do a new tab? Open a link to a new tab. Close current tab, go create a new tab. Okay. So dot adopt. I see. I see. Might not be good. I gotta manually resolve these errors. Okay. Go back. I'm trying to think. Alright. Hmm. Hmm. I keep on thinking, what am I doing? Move ZSHRC to dot files. Go to dot files again. Go dot. Okay. Then it means in here, remove dot ZSHRC dot pre. Okay. Go dot. Yo, why is that taking? Okay, so that's working. Now the linear mouse changes. We just might want to copy linear mouse over. So move dot config linear mouse JSON. Oops. Wait, how do I escape? Wait, I can't escape. Hello Fig. Wait. We're moving this to dot files dot config linear mouse. That works. Its status. The linear mouse changes and the HRC changes. SLS. Okay, so that's fine. Close this. Close this. I feel like I'm missing a lot more of I Is there a Omo ZSH interactive? I feel like there's a quick start that I missed. So I'm gonna go to the top. Wiki. I didn't know that. Okay. So OMZ update. OMZ reload update versions themes. list. Shit, man. Is there a cat pigeon? Nope. Cloud, maybe we'll just go for cloud. Ooh. So there's oh my ZSH, what was it? I guess I gotta check out the plugins, right? Home Z plugin. One password Xcode. That's a lot. Terminal tab tmux? Tmux? There a tmux plugin. What does this mean? Alright. Let me check chat for a sec. Mohammed Jamal. How long did it take for you to understand your first problem? Well, the first problem was pretty much two-sum, right? Honestly, it probably took me like an hour. Because maybe I was persistent, trying to figure it out myself, but I couldn't, right? There's no problem with that. There's no problems with that. Now that's somewhat installed on my ZSA. Ignore. I want to try this theme. I understand. Okay. CDI. There was a way to install CDI through my ZSH. I'm gonna check that out. So this is, what's it called? The oxide. Half page down. You go down on this. And just go D. Yes. So there was like a... Oh, my ZSH was never... Okay. Never here. Okay, so... I guess I'm taking it from my other... Go into dot files. Wait. Okay. GG, YG, dude. What's up? What's up, Vig? You can't jump there. Come on. Okay, dot ZSH RC. Oh no. Fig's on the keyboard. Okay, Fig's actually alright right now. He's alright. Oh. Bop. Oh. Oh, there goes the cat steps. Cat steps. Okay, ZSH RC. At the very bottom. Wait, at the very bottom. We want to new line and paste. Yo. Not a lot. What's happened here? Isn't what I expect. Oh. Bit override. Bit override. Bit override. Okay. Vim. Okay, GG. YG. There we go. Go to the bottom. And we paste. Cool. So look, we added all there is to add. I quit. Now I hope this means that OMZ, what is it? OMZ reload will just finish things up for me. CD to Leetcode. Perfect. Okay. Hello Roblox. Blox Hub Roblox. Got a cat right next to me. Shrigal, which programming language is this, bro? It's not a programming language, it's just a command line, man. Okay. With that said, I'm actually going to start programming. I'm going to do a Leetcode problem. Okay. Leetcode side here. Now, we have a few options. Do some intervals. Insert interval. We're going to try this one. Try this problem. Insert interval. Word break. Insert interval. Save the bookmark. Did you buy Leetcode? No, I didn't. I'll never buy anything just to prove that you don't need to buy it. To prove that you don't need to buy anything except maybe an education. I would say that's the only prerequisite for me. In my scenario, that is. Okay. Now let's. My thinking is, how am I gonna do this problem? I want to say do this in NVim, but I also want to fix this TS error. So TS is deprecated, use TS ls instead. I'm just gonna search that up real quick. So TS server is deprecated, use TS ls. Then you covering DSA, please help because I want to cover DSA too. Give suggestion. I mean, what do you mean? What type of suggestions would you like? LSP config. Okay, so if this is an LSP config, quit all. We're gonna just we're going into let me see. Going into my config, so we're gonna go into .dot files here. And .config nvim. Actually, it doesn't matter if I go too deep and then just nvim from here. Check this out. So nvim. Ooh. Okay, wait. I gotta use this way more to actually use it well. From where should I learn DSA? Any YouTube or Udemy course? Anything? I would just say go learn it from Geeks for Geeks. And what's the other one? Geeks for Geeks. Or no, actually Geeks for Geeks is the main one. Right. Learn the DSA from that. That's what I would say. Yeah. I don't have any specifics to tell you. So I will say, you know, there could be Udemy courses, there could be YouTube courses, but I don't know of them. All I've done is my university subject plus yeah, extra learning from like Geeks for Geeks. Okay, TS server, I think. Okay, wait, how do I do this again? So I think it's like, what's the command? Leader. Oh, space is my leader. Hmm. Hmm. I see. Oh, leader X. Yeah, leader X. Leader. Damn, this is hard to remember. Dash FF, yeah. Dash F all TS server. Oh, dash F word FW TS server TS LS. Okay. Dash F find old files. Find files. Find all files. Yeah, but finding all files doesn't work either. G GT diff preview. Oh, yeah, that's actually good. Okay, I like that. M find marks. I don't know how marks work. Okay, but okay, sure. Oh, whoops. P does go pick hidden term. Okay. R R T. Wait. R relative numbers. What are the advantages of using Linux instead of Windows? Doesn't it kind of boring though? What do you mean? Windows or Linux? I don't understand that question. But hello Void, welcome in. Your language server failed. Language server missing from. Okay, so that's also another thing that I gotta fix. That's something I gotta fix. There's so many little things here. So don't worry about it. Can't be fucked either way. I'm just here for one thing and one thing only, Leetcode problems. So let's try and do that. What was this? Right, so after I finish this Leetcode problem, I'm probably good. Because this is probably the only one that I'll do actually. Now that I've set up my ZSH. Does mean I can take this off now. Set up my So gotta have this here. Okay, let's try and fix this, solve this problem, and then I'll be able to do some other stuff as well. Okay. We're given an array of non-overlapping intervals. Let me think. Holy moly. Intervals and new interval gives you a list. And this is specifically an intervals problem. It is specifically an intervals problem. And yesterday I did, or the day before I did, partition equals subset sum, partition equals subset sum. I see. That was like a Leetcode problem. That was like a dynamic programming problem. Alright. Okay. Insert interval. Okay. Trying to sit somewhat comfortably right now. You are given an array of non-overlapping intervals where interval I, start, I, end I represents the start and the end time in the ith interval. Intervals is initially sorted in ascending order by start I. You're given another interval, start end, new interval, start end. Really? Insert new interval into intervals. Such that the intervals is still sorted in ascending order by start I, and also intervals does not have any overlapping intervals. You may merge the overlapping intervals if needed. Return intervals after adding new interval. Intervals are non-overlapping if they have no common point. For example, 1 to 2 and 3 and 4 are non-overlapping. 1 and 2 and 2 and 3 are overlapping. Intervals 1, 3, 4, 6, new interval 2, 5. Then it's 1, 6. But if you have intervals 1, 2, 3, 5, 9, 10, and 6, 7, you can just add that in. What's up, George Vell? Thanks for joining. Okay. I understand the problem, except how do you make this efficient? Generally, how would you go about some problem like this? Me at least, I would think if you had that 1, 3, 4, 6 problem, 2 and 5, you'd notice that the start is at 1, which is before 2, and the end is at 3, which is less than 5. So you would add, would you add this all to like a priority queue? Would you? Why does this look like a priority queue? Because then if that last number is greater than the next number, you want to merge those two again. But if you have this priority queue where 1 and 2, 3 and 5, 6, and 7, you got 6, 7. 7 is less than 9. Not a priority queue. But there's something about merging that needs to be done here. There's something about merging that needs to be done here. I'm just trying to think how that would work. This is definitely a question that... This is like a question that I did in like a TikTok interview. Let me think. How could you solve this? How could you solve this? I'm gonna be stuck in the next 2 minutes, I think. I'm gonna be stuck. 1, 2, 3, 5, 9, 10. Let's try and break this down. So the start and the end is important, right? If you start at 1, two is less than 3. Does that really matter? Yes, it does. I mean, if you add it all to a heap, it can be merged down. But then, for those that don't merge down, you can't pop off the heap. And get it working continuously. If anything, it has to be a queue. How do you insert to the queue? No, that doesn't work. I think those data structures don't really match what we're trying to do here. I mean, if you notice that the end is less than the start, the new interval, you can pop it off, don't need to do anything. 5 is less than 6, pop it off, don't do anything. 9 is less than 6, no, so you add 6 in front. Then you check if 7 is less than 9, yes it is. If it isn't, then you merge the two. So that's checking the first number each time. But if you had like 7 there, like the first number is less than 7. Or you're checking the last number is less. I think the last number would be. Fuck. Well, let's just try some rudimentary example. We make it into a queue where collections EQ of intervals is what we have. While Q is not empty, Q.pop start end start if start if end is less than equal to less than new interval start, then you just continue to the next. Else, if it's not, then you would want to check that the start to new interval end is like added to the queue. Wait. How do you add it to the front of the queue? Like you pop left. So this is popping, but not popping left. So we need pop left. Oh, you got the. I see. You got the MacBook. Awesome. These nuts came in the mail today. Hope you enjoy your new MacBook. Okay. See. Now you can append or you can prepend. If you prepend, then you always pop left. If you append, then you always. It has to be that way. So we have to add it to the front of the queue. Wait, honestly, how do you prepend? Why is this something I've never done before? Yeah, how do you prepend to a list? Oh, you can append left. You can append left. Okay. Append left. And then you check again. Okay, I don't know, something like this. Return the, I guess the queue. Is that it? TLE. Oh, right. The queue never reduces further. Yeah, wait, why did I think that was the play? Ooh. So queue is almost like the data structure. And it's not the thing we iterate over. Yeah. The queue isn't what we iterate. Well, yes it is. But you can't do it while queue. Because it's always going to be like that. For, I can't say for either. While queue and you don't know how many times it goes, right? Or you do. You iterate once, iterate a second time, iterate a third time, iterate a fourth time, iterate a first time, iterate a second time, third time, fourth time, sixth time. So the maximum times you can iterate though is the length of the intervals. But none of the intervals, but you can also end quicker. So if end is less than new interval 0, then you keep on going to the next. if the end is you never insert just the interval itself. If end is less than new interval 0 and start is less than is greater than wait. Kind of need the next one. Q0 1 0 is greater than new interval 1 q dot append left start end and q dot append left ooh wait, this goes above new interval. Okay, this is dodgy and I'm pretty sure I missed something. I feel like I would have missed a lot. Yeah, I is not defined for sure. I is equal to 0 originally. And I gets incremented every time. One, 5, 4, 6. Well, that's also wrong. But anyway, it's a list that I need of 5, not a DQ. That's still wrong, right? So 1, 5, 4, 6, you connected it, but then you stopped checking because you reached the end. While you don't know what how many there is in total. Maybe you check that the queue previously is the same as the queue before, right? Fuck, so this I've done this type of shit before. But say instead like when the queue doesn't change anymore, that's when you know things are all right. So this is equal to the len of prev q, we're going to call it. And we're going to call the prev q is equal to q currently. Let's hope that copies over. Or I should at least I should just do this, len of q. And then prev q len is what I want. So just get rid of this. Prev q len. This is kind of smart, I think. This is kind of smart. Alright, we'll see. Oh yeah, of course. Now If it's your first time iterating through, let's see. Ah, shoot. Let me think. No, I definitely think I did this I might have done this a little wrong, but I think still kind of smart. I feel like I'm close here. So we need prev q length initialized, which I might just make it len of q plus 1. Just make something like different because it's gonna be different. One, 3, 4, 6. Does that make sense? 1, 3, 4, 6. 1, 3, 4, 6. Like the interval doesn't even change. Did anything change? You know what I'm saying? Well, let's have a consider. So the end less than 2. No. The end less than 2. No. You append left that interval. Wait, end, which is 3, is less than 2. No, it isn't. If it isn't, yeah, no. That's a good try. Good try. Let's have a look. Linear search, binary search, greedy. The fuck? Okay, these are somewhat smart.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem insert interval. And this is actually another problem from the blind 75 list, a list of 75 common Leetcode questions that we've been tracking on this spreadsheet. We're almost done with all of them. Today we'll be solving this interval question, insert interval. So basically we're given a set of non-overlapping intervals and we want to insert a new interval into this list of intervals. We want the intervals to remain non-overlapping, so basically we might have to merge some intervals because we are given a single interval. We're given a list of non-overlapping intervals, in this case 2, 5. So when we insert this interval in here, you can see that 2, 5 is an interval, right? Suppose we have 1, 3, and then we have 2, 5. So clearly these two intervals overlap each other, right? So then we have to merge them together. How are we going to merge two intervals together? Well, if they are overlapping, we're going to take the minimum of both of them. In this case, it's 1, and we're going to take the maximum of both of them. In this case, it's 5. So that's what the new interval is going to be, right? So we merge them together. We'll have a new interval like this, 1, 5. And so this is a new interval. And then you can see we have another interval, 6, 9. Now 6, 9 is not overlapping with 1, 5. So in our output now, we're going to have two intervals, right? We're going to have 1, 5 and 6, 9. And then we're going to return these intervals in the output. Now, the convenient thing is that these intervals are actually already sorted for us in ascending order based on their start times. That's good because that means we are not going to have to sort them. And if you've solved any interval problems before, you know that sorting always comes in handy for interval problems. And I don't know if they specify in this problem, but just so you know, an interval such
sorting always comes handy. In interval problems.
as this, let's say we had 1, 2, and another interval 2, 3. These do count as overlapping because these 2 points technically are connected. So this would be one single interval, 1, 3. I don't know if they mentioned that somewhere in the description, but that is just an edge case that we'll have to keep track of. Suppose we were given a list of intervals such as these, right? These are sorted in ascending order based on their start value, so none of these are overlapping, which is what we expect. What if we were given an interval such as this one, an interval that actually goes, let's say this is 0, right? Even though I don't know what kind of interval would end at 0, but let's just assume it is, right? So that it doesn't overlap with this one. So since even this interval, right, the end value is less than the start value of the first interval, that means this interval is not going to overlap with this interval, right? And if it's not even going to overlap with the first interval, then there's no way it could overlap with any of the upcoming intervals either, right? So when we basically return our output, we're just going to return this original list, but we're going to add this interval at the beginning, right? So that they're still in sorted order and they're non-overlapping. Now, what if the opposite was true? Suppose we were given an interval such as this one, 7 to 8 or something like that, right? Where the start value of this is actually greater than the end value of the last interval, right? In this case, this interval won't overlap with any of these, and then we can just return the original list and adding this to the end of the list, right? Now, those are a couple of the simple cases, but it's possible that the new interval could actually end up overlapping with one of these other intervals, right? And then we'd have to combine both of these. It could be possible that the interval actually could overlap with multiple intervals in the input, in which case we have to combine multiple intervals, right? Or it could be that the new interval would actually go somewhere in between a couple of these and not overlap at all. So how are we going to determine where exactly this new interval ends up going? Well, we'll have to iterate through these sorted intervals and then basically find the insertion point of the new interval that we're looking for. So we're going to go, suppose we have an interval like this one, right? Somewhere small in between here. We're going to go interval by interval. We're going to see, okay, this is the first interval. Does this overlap with our new interval? It does not. So we would take this, add it to the output. We would look at the next, and we would see that this interval goes after that. And then we go to the next interval, and then we'd see that, okay, this next interval actually goes after the interval that we're trying to insert, right? Suppose we had a really small interval like this that goes in between. Then what would we do? Well, we wouldn't want to add this one to the result first. We would want to take this new interval, add it to the result, and then add this to the result. And then at that point, we can just take the remaining intervals and then add them to the result, and then we can return. So those are a couple more of these simple cases, right? Where we would not have to merge. Suppose we had an interval such as this one though, right? Let's say 0 to 3 or something like that. Okay, we iterate through the first interval. We see, okay, this interval is overlapping with this one. How do we know if they're overlapping or not? Well, we would check, okay, does the end value of the new interval, is it less than the start value of this interval? It's not, okay. Is the start value of the new interval greater than the end value of the current interval? It's not. So if neither of those are the case, that means this interval does not go after this interval and it does not go before this interval. So that must mean that they are overlapping, in which case we're going to merge them. How are we going to merge them? We're going to take the minimum of the left and the maximum of the right and then merge them together. So when we merge them, we're going to get a new interval such as this one, 0 to 3. And once we have this merged interval, we're not going to actually add it to the output just yet because we know that this interval could actually overlap with some other intervals that we now have that come following, right? And that's exactly the case. It's overlapping with this other interval 3, 4. So we've gotten rid of this first interval. Now we're going to be iterating to the second interval. We're going to see 3, 4. Okay, is this overlapping with our 0, 3 interval? Yes, it is. So we're going to merge these as well. We're going to take the minimum of the left, it's going to be 0, and the maximum of the right, it's going to be 4. So we merge these together. So now we're going to have a new interval from 0 to 4, and we're still not going to add this to the output yet because it could technically still be overlapping with some following intervals. In this case, we're going to get to the third interval, and in this case, they're not overlapping. How do we know that? Because the end value of this one, 4, is less than the start value of the interval that we're at. So what are we going to do? We're going to take this, the first interval, add it to the result now, and then we're going to take this interval, add it to the result after it, and then we're going to go to the next interval, see that we don't have any more intervals remaining, and then we're done. So this is going to be our result in this case.
Right.
0, 4 and 5, 6 are new intervals after we've merged
that is
them,
kind of what
and
I was
they're
thinking,
in
but
ascending order.
you're not
So
using any
that's kind of
queue.
the general algorithm.
Well, kind
As
of.
you can see, since it's already sorted, we'll just have to iterate through the entire list of intervals once. So the overall time complexity is going to be big O of n. That's also going to be the memory complexity if you count the memory that we're going to use to create the result array. With that being said, we can hop into the code now. And so we are going to have a result of intervals. And as I mentioned, we're going to be iterating through every single interval in the input. We're given a list of intervals. They're already sorted in ascending order. So now we want to know the couple edge cases, remember? So basically, if this new interval,
This one's a lot of edge cases, hey.
it goes before the current interval that we're at. So suppose the end value of this new interval is actually less than the start value of the interval that we're at. So how do we get the start value? Well, interval at index I, the 0 value, this is the start value. And so basically, if the new interval has an end value that's smaller than the start value of the current interval we're at, what are we going to do? Well, that means we can go ahead and take this new interval and insert it into the result. So we'll say result.append new interval. And once we're done with that, then we basically know that all the intervals that come after it are also going to be non-overlapping, right? So we don't really have to do anything. We can just take those additional intervals, append them to the result, and then return. So in Python, an easy way to do this is result plus intervals, the sublist starting at index I going until the end of intervals, right? So we can just take that entire sublist and append it to result. You can do that with the addition operator, and then we'll just return that, right? We don't even have to continue this while loop. Now, the opposite case we discussed, remember, was else if this new interval actually goes after the current interval that we're at. Well, in that case, then that means the new interval could actually still be overlapping with some intervals to the right. So we're not going to add the new interval to the result. Let me write the condition. So basically, if the new interval, the start value of this new interval was greater than the end value of the interval that we're at, then we're to the result. We're going to go ahead and append that interval that we're currently at because it's not overlapping with this new interval.
VB, bro, this problem was kind of easy by brute force. I sort of belong with you. Oh yeah. The thing is, I over-engineered this shit, I think. Okay. So well done, BB. Good shit.
But we're not going to append.
Yeah, like honestly, it is quite obvious. But I was thinking like maybe I could use a queue, but maybe. Yeah, no, maybe just an iteration through is all I needed.
Interval just yet because it could technically overlap with some additional following intervals that are coming up. And the last condition, so these two conditions are if the new interval was not overlapping, but the last condition else if neither of these evaluates.
So, okay, hold on. He said he just didn't, okay.
Value of this new interval was greater than the end value of the interval that we're at. Then we're to the result. We're going to go ahead and append that interval that we're currently at because it's not overlapping with this.
Yeah, non-overlapping.
And the new interval just yet because it could technically overlap with some additional following intervals that are coming up. And the last condition, so these two conditions are if the new interval was not overlapping, but the last condition else if neither of these evaluates to true, that means the new interval is overlapping with the current interval that we're iterating through. So what are we going to do? Well, we want to update the new interval in that case, right? We want to merge it with the interval that we're at. And remember, how are we going to do that? Well, we're going to take the minimum of the left value of both intervals. So this is how we can do that. The minimum of the new interval and the minimum of the current interval we're at, and the maximum of the right value of both of these. So let me copy and paste.
Yeah.
And the right value is going to be at index 1. So we
Yeah.
have to change those indexes. So this is what the new interval is going to be set to. Now, once we've updated that new interval, right, we basically merged it with a different interval. Are we going to add this new interval to our
Not
result?
yet.
Well, not quite, because remember, this new interval could still be overlapping with some additional intervals that are coming up. So we're not going
Yes.
to add it just yet.
So
And
what do
then
you do?
at the end, so once this entire loop is done executing, we're going to go ahead and return the result, right? But remember one thing. So there's two ways that we could have exited, right? One is that if we ever got to the point where the new interval was, basically if this if condition ever executed, if the new interval was not overlapping with a interval, then we go ahead and add that new interval to the result, and then we return, right? But if that never executes, then we're never going to end up adding the new interval to the result, right? So what we want to do before we return the result is go ahead and take to result.append that new interval before we return, right? Because that means basically we definitely want to append this new interval to the result, right? That's kind of what the function was telling us to do, insert the new interval. So we want to make sure that we do end up executing that. So once that's done, we have written the entire code.
Really?
And as you can see, it is a pretty efficient solution. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel. Once that's
Wait. How does that function? How does that function? Because you see, the problem that I'm trying to understand is you iterate through all of that. You append an interval or you append the new interval. I see. You just set what the new interval is, which means then you can add that to the new interval when that condition is met. Ooh. Nice. I see. And then while that is always true, you just add the rest of the intervals. However, why not just you have this, you break it's interesting. Have a look at your code, VB. Show us. Show us your code, VB, on Discord. I'm gonna try quickly write this up now myself. Okay. Okay. Reset everything and think this through. Understand the conditions. Actually, one thing I do want to understand more is what's the linear search? What's the point of linear search here? Like, what's the point of the searches here? Let me see. Intervals I1 is less than new interval 0. You add that interval start. Wait, that end is less than the start. That's when you add it. Then you do a second run. The new intervals so end is greater than or equal to the start of any of these. You would new interval 0, 1. You would make that apparent. Wait, while I is less than n. So you check this first before you continue with the rest of the checks. Okay, so you say you check where it starts, then you check where it ends. Make sure that right. And then while I is less than n, you append the rest to get your result. Fuck me, that's linear search. Yeah, that's linear search. What about binary search here? Why would binary search be used here? If not intervals, turn new interval. So, right, that's just a base case. And then if you have n is equal to length of intervals, target is that value, is just the start value. Left and right, and then while left is less than or equal to the right, the mid you can find intervals. If this number is less than the target, then it's going to be on the left side, else it's on the right side. And then you would insert when they become equal, that's when you insert left. Insert at that position, the new interval. So that's only inserting. And then you would need a check for all the intervals. If not res, then you would append, or if the last end is less than the interval 0. Is less than interval 0. Oh yeah, you would just append the interval. Otherwise, it's not. It's greater than or equal to. Then you want to take the max of the result -1, 1. So that's the end, or the end of interval 1. Holy. Okay, I see how that works as well. This is definitely opening my brain a little bit to some more, or I should say like less data structure based. I would say it's, this is more of an array problem. This is a type of an array problem. You know what I mean? The type of array problem. Okay. Now, binary search makes sense, and greedy. Got to think how this is greedy. I'll look at your solution after I look at the greedy VB. Okay, so okay, the greedy solution is his solution. But how is this at all greedy? I'm confused at how this is a representation of greedy. Let me just have a quick look here. We're going to use ChatGPT. Oh, okay. How is this greedy approach? What the fuck? Hmm. Okay, yep. That's cool. Okay, the link, I cannot see the link. Unless, it's... Yeah, no, I can't see any link. Alright. Alright, let's see. Let's see. I'm gonna sit my head back, slouch a little. Slouch and solve. Let me think. I want to solve it in a search. It is definitely easier than it looks. When it's not this anymore. Wait. When it is continuously this, res is dot appended with intervals I. Res is originally nothing, and it's also originally what we return. Okay. Once you get to the stage where wait. I don't need to do it this way. Intervals I1 is greater than new interval 1 res appends intervals well actually you don't append anything and you increment. It's like 3 modes of checking. Can't do it all in one. You can see that now. If this is now this greater, you would do nothing. Then you get to a point where y is and res to append intervals damn it, wait, okay, intervals I is 1 greater than new interval 1, then because you know you already added all the ones that you could, let's see, Added the ones that you could. Look, I should always do this with an example, but it's also like multiple possible edge cases, which makes it like bad to think about. So I want to think about like this holistically, right? Unless you have to go down to examples, which you might have to. Oh, God damn it. What's the thought here? Ah, wait. I'm still doing this almost wrong. I can't believe I'm still doing this wrong, man. Okay, fuck. I is equal to 0. This part has to be new interval 1. If this is greater than equal to intervals I 0. Okay. God damn it. Wow, this is crazy. I put 2, 3. Wait, what? Let me have a look here. Res I. Intervals, new interval. Oh. Yep, that would make sense. Okay. Cooked. Okay. Whoa, jump game. Okay. Hmm? Hmm. Okay. Okay. Cool. That's it. 2 hours for this one question? Not really. Like, I mean, I've tried to do. Yeah, it's more like an hour and a bit more, but still should try and do them faster next time, I reckon. I will try to do that. Because then I can get through more merge intervals. I guess merge intervals is also something I could do. So given an array where intervals start and overlapping and return an array of non-overlapping intervals, I cover all the intervals in the input. Intervals are non-overlapping if they have no common point. For example, 1, 2, 3, 4 are non-overlapping. 1, 2, and 2, and 3 are overlapping. 1 and 3. So this then is something similar. You could probably do this similarly. Hello, Millie. Can I ask a super newbie question? Of course you can. Of course. Please. Okay, merge. I guess these are the type of questions that need to be done. It's just the way that it has to be done. Then you just have to think about the very edge cases while scanning through it once. So it's like a greedy. Technically, so the previous one was also a greedy, I believe. How do we think about this? Let's try 4. I'm self-studying programming, specifically Python, but I get stuck up on taking notes. What do you take notes on, or do you just keep writing code until it all makes sense? I would say you have to take notes. It's just a matter of the notes that you think which are important to take note of. For me, I keep my notes here, right, on Obsidian. It's if it was for Python, you know, if there was any particular piece of Python-specific syntax that I don't want to forget, I would write it down. So, you know, oh shit, I didn't know Python could create a queue using DQ. So DQ, something like this, right? I would write that down. This represents a queue in Python. So this is what I would have. You know, I have stuff like this already, but for Leetcode specifically. So it's not Python specifically, but it's for Leetcode. So I've what is mine is called a boilerplate. So this is like a list of boilerplate code or information that I need for each of the different types of questions. Now this is boilerplate code, but necessarily it also is like a way to remember how to write specific types of questions. So just always have your notes pulled up, reference. Yeah, that's it. So you can think of like writing your notes as writing a little document for yourself for later reference. That's how I think of it, basically. Okay, so I gotta consider some edge cases here. But when you reach the end, what happens? Ideally, it should have already been merged, or if not merged, it's already been considered to be merged. When it's considered to be merged, you still want to add that last part. Only if it wasn't merged. Right? So you can maybe think of something like the resulting set being where you start off with the interval, right? Intervals 0. Start off with interval 0 in here. And then that means maybe you start from 1 to length of intervals, in which case you're perhaps going to be considering like post addition. Post addition, the start is the start. is the end less than the start. Yeah, so intervals I minus 1, 1 is less than this, should be. If it is less than that, all good, Millie. If it is less, no. Okay, wait. Let me think. I'm losing concentration. But if it is less, so if the previous value is less than the current start, then you can, there is no merge conflicts, no overlap. So intervals I. Right? So otherwise intervals I minus 1, 1, I minus 1, are we talking about I minus 1 though? Or are we talking about result 1? Should say result. Minus 1. If if the end is less than the current results start, wait, let's think the current results end, the interval starts is less than the current result end. The result end is less than, then you would append if overlaps. Come on, overlaps. If whatever's in the result right now overlapping with another thing, an interval, it means the end of the result is greater than the start of the intervals. Yes. They're greater than or equal to. So why not I just go else? Else what? We append this new interval, which is the max of the min of something and the max of something. Min-maxing? Maybe. The min of one or whatever start. So res -1 res dot oh shoot, man, it's just so not considered. So we pop interval, we'll just call it interval. Interval 0, intervals I 0, interval 0, intervals I 1. I might have missed you explaining it, but what does it mean for two intervals to overlap? Well, right, if you, it's just pretty simple math, right? I would think, but you know, if you have an interval between 1 and 2, so your interval is 1, 2, inclusive of 1 and 2, then, and if you have another interval of 1 and 3, then they overlap in the region of 1 and 2, right? So in this case, you want to merge the two so that your final interval is the union of those two intervals. And that's what it means by merging the two intervals. So it's 1 and 3 as your final merged interval. And then if you had like 1 and 2 as your interval and 2 and 3 as another interval, it's still considered an overlap with 1 and 2. Sorry, with on the 2 position, so the start 2 and end 2 still overlap in this case, and then you would merge that to get 1, 3 in total. Yeah, okay, yeah, it's yeah, you got it. It's not hard. It's not hard. Okay, output none when you return, when you need to return something. O4. Okay. Okay. It's not sorted. It's not sorted. Should sort this. So intervals is equal to sorted intervals with a lambda. I think you need a lambda somehow, and I forgot how to do that exactly. So intervals dot sort. I think that might be fine. Maybe not. Rate limit exceeded. Intervals dot sort just sorts it. Oh, why? Doesn't matter. Yeah, it just doesn't matter. Yeah. Okay. Well, that worked. Right? I figured this one out pretty easy now. But let's see if it works here as well. Oh, shoot. I'm not logged in. I'd like to log in. Keep my progress. Yay. Okay, it was it's an accepted solution. I'm happy.
Hey everyone, welcome back, and let's write
watch
some more
the
neat code today. So today let's
video
solve
solution.
merged intervals. We are given an
I want to kind of look at this first though. The sorting. You sort by 0. Yeah, so this is the kind of syntax that I need to remember. The key being a lambda where pair 0? Pair 0. We're taking the key as 0, right? The pair or the interval. The interval should kind of be like, interval is kind of what we would call it. Interval 0, right? So this should still give the same solution anyway. Whoops. It actually performs worse. Submit again. Oh, it doesn't matter. It performs even worse with what I had. This really doesn't matter. Okay. Okay, but this is important to know in terms of just like dealing with sorting. So this is something that I'll put in my boilerplate. So this is intervals. Dynamic programming to intervals. So okay. So start end intervals, last end output -1 to 1, start last end output -1 to 1. Ooh, oh yeah, no, that's right. Start end, last end. What would the last end? Yeah. Ooh, you add it directly to it. Right, if start is less than equal to last end, then you take the max of last end into end. How devastating would it be to lose your vault? Pretty bad. It'd be pretty bad. Although I have backups, so I have yeah, I've pretty good backups. So if I really lost everything, I could get it back. Just it would take some time. But yeah. Okay. Sorting time complexity of n log n. So I think that's something I gotta write here. I solved this problem on my own. O of n log n time with time and space. So space complexity would be, I guess, since you're just building out this array, it's O of n. Ooh, O of 1 or O of n, depending on the sorting algorithm. So is quick sort O of 1 or O of n space? Quick sort has a complexity n log n in the average case. The arise recursive function. Balance partitioning. O of 1 space. Space complexity O of n is merge sort of 1 or of n. Merge sort is O of n. Why does sorting, which sorting algorithm has O n log n and O of 1 space? Algorithm with O of n time space complexity. Oh wait, what? Kusha, hello man. I'm here after a long time. Can you tell me what's going on with things you're working on? And what about the Amazon job? Yeah, I can give you a little idea. So like, I don't know, possibly since last time, I've reached my 100th Leetcode problem solved. So yay. The Amazon job is like 4 weeks in now. Technically at the end of the 4th week now. So there's been lots of stuff that I've learned. I will say I am becoming more complacent. So starting next week, I'm going to try and not be more complacent. Because you know, when you become complacent, things will turn out, you know, not to your favor. You have to always be on your edge, basically. You have to be on the edge. Because if you're not, then you're not learning. Especially for an internship, you want to be continuously learning. I would say that's a little update there. So, Millie, how long do you plan on streaming your self-work, or do you not even think about it? Yeah, I don't really think about exactly how long. But I plan to go for another 30 minutes maybe, or even less. Depends. Ooh, got fig. We got cat on. You guys can't see, but the cat's here. Yeah, I'm still going for a bit. I don't really have a set schedule. Although I have a set number of things that I want to do, so I gotta keep that in mind. Gotta keep myself checked in. I gotta check in with myself. Also, checking in with myself, I'm becoming more aware of checking in with myself, especially during this internship, because you can easily get lost in stuff and go down a rabbit hole. But without checking in with yourself, you continue with that rabbit hole. But when you do check in with yourself, you I guess regain the larger picture in the end, and try to see and you better understand what you're really meant to be doing there, right? And also, 12 weeks is nothing. That's another thing. It's already a third of the way through the internship for me, and I don't feel like I've even really started coding. You know what I mean? It doesn't feel like I've done much for the team. But that's the way it is, right? That's the way internships go. And yeah, that's the fun of it. Oh, you mean in general, like a couple months or another year? Nah, I've not thought about that. I think I'll be doing this for a time. This is gonna be. I'll continue to do this, like even for next year, because next year is the last year where I'm studying also. But you know, we also have to see. Yeah, I would try and figure out ways to even do more streams still after uni. Just if not streams, it's videos, right? Gotta think of these regardless. I started journaling as a way to check in, surprisingly really helpful after dismissing it. Yeah, right, yeah. That's good. I journal sometimes, but not much recently, but I used to quite a bit. Basically every day. Yeah, just throwing words on a notebook. Now I would encourage you, when you are writing words on a notebook or words in a journal or a digital journal, to try and write them with quality over quantity. Because I would say personally, I wrote too much quantity in some of those. Like, I know you're not even meant to read it in the end, right? But yeah, maybe you can write a lot of quantity. But I'm starting to think that quality might be more important. So that's also something I'm thinking about. Although, you know, who's going to read the quality? If anything, the quality is just training a better way to express yourself. And I think that's what I'm trying to do more of. But, you know, everyone's on a different path, right? So maybe we have to all go through a stage of quantity before we refine on the quality, I would say. Right. So maybe what I just said was totally useless, is what I'm saying. Yeah. Hopefully I literally just rambled. Okay. Harold, what's that Leetcode note tracking app? Well, this one on the right here is just my note taking app that I'm using called Obsidian. With quality, you also have to take a second and think about what you're really trying to say. Yes, that's true. Exactly. And that's what I want to promote more of for myself. Heap sort is an algorithm with a time complexity of O of n log n, and a space complexity of O of 1. Really? Does that make sense to me? Using heaps? Ooh, is that really an optimization? N log n. Merge sort has O of n. Okay, but these sorting considerations are important, I think. Could I perhaps get away with, you know, a heap? If you use a heap sort, you are just taking the last value out, right? I think we need a discussion on this. Now the greedy, whoa, time complexity n plus m. Space complexity of n. Interesting. Sweep line algorithm is also interesting. Okay, these are actually quite intense. One thing I will say is, okay, oh, it's more consideration of exactly what you have here, an output of this, or you're doing it in place. If you do it in place, then it's O of 1. If you don't do it in place, you're creating a new output, then it's O of n. Right, wait, no, okay, fuck. It says depending on the sorting algorithm. Doesn't matter. Never mind. I need more explanation on this. I need more explanation on this fucking line. But I'll say a possible optimization is to use heap sort. Because you can build out a heap. Oh, wait, no, it's still, it's O of n. Time complexity, would that be O of n? Base complexity, O of n. Time complexity is O of n, that's worth it, no? You get rid of log n. But then maybe you can have an O of 1 space complexity. Fuck this. This is so many ways to think about the sorting, the way you go about sorting. Okay. Millie, I don't know how to explain it, but you're a really cool guy. I appreciate it. I appreciate it. Thanks for the kind words, man. Man or woman. One possible optimization is to use heap sort, as time complexity is O of n, and space complexity is O of n. Could I do it? Let's have a go. I want to have a go by basically copying this. Wait, firstly, let's save this, right? Alacrity. We go into Leetcode. This is number what? Oops. 56 merge intervals. Paste. Okay. Alright, I want to have a go at doing this using a heap, right? So, if I do it using a heap, intervals becomes heap q dot heap fi intervals. Alright? Now you heapified it. It'll still, I guess, keep by the lambda of the pair, so the pair being the interval with the interval of 0. I'm assuming this is what you can do here with heapify. Like, that whole key argument doesn't necessarily need to be there, but we will see. And then we can say heap q heap pop from intervals, this value, right? That's inside there now. Once it's in there, now heap q heap pop intervals zero, append the intervals. Ooh. I need to save this in another. Right, so if this is heap popping interval, maybe we just call it interval popped interval, right? Popped. Heap q, heap pop, intervals. KW, KW, KW. Popped. Okay. Popped. Popped. Intervals I is still going to be popped. Intervals I going to be popped. Popped 1, and then that should be it. See if this makes a difference. Runtime error? Is it just because the module doesn't exist? I think so. From collections, import heap queue. So, yeah. Okay. Wait. Import heap queue. Shit, it's not even from collections. One of these days, I'm going to hop in chat after not it and help bro with Leetcode problem. Let's go. Hope. I really hope we can do that, man. Takes no keyword arguments? Okay, so you can't use a key here. That's fine. Wrong answer. So the output is this when it was meant to be this. Ooh. Wait, so true. So could I then change this whole line to while intervals isn't empty? Let's go. So you can use a heap, which I've just proved. Okay, well that's bad. But would you use a heap? Would you ever use a heap for this problem? Oops. I don't know. I don't think you would. Maybe. You might argue something during an interview. I'm just gonna write my original solution here as well, just for convenience. And this was 25 minutes ago? Alright. Already 25 minutes ago. Wait. No. Nope. Oh, the code's here, I see. Can I just copy this and paste it? Yes. Yes, I can. Okay. Cool. That works. Can we close? I'll watch this video now.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve merge intervals. We are given an array of intervals with a start and an end value. So an interval is a start and an end value. You can think of it like a class or a meeting or some kind of time period or whatever. And for each of these intervals, we want to take all the overlapping intervals and then merge them. And then we're going to have a new output array of intervals, and since we merged the overlapping intervals, the result is going to be non-overlapping. So in this case, we see we have interval 1, 3 and 2, 6. So these two are overlapping. We can merge them into one interval, 1, 6. The remaining two intervals are non-overlapping, so they do not get merged. And then we see that the output has 3 intervals, one that we had to merge to get, and then the 2 original. And this second example just basically clarifies that if we have one interval, 1, 4, and a second interval, 4, 5. Now, these aren't technically overlapping in a sense, right? Like we have 1 to 4 and 4 to 5. So they clarify that these two actually do count as overlapping. So what's a good and efficient way to solve this problem? Let's say we're given the exact same 4 intervals that we were given in the original example, but notice this time they're out of order. This one is 1, 3, this one is 8, 10, this is 2, 6. It was originally over here, right? They had given the input to us in sorted order, right? So that's kind of a hint that it might be helpful for us to keep our intervals in sorted order. But what's a good way to kind of visualize what's actually going on with these intervals? These numbers are pretty descriptive, but it's better to have a picture to look at. So I'm going to draw a number line, and we're going to start at 0 because they clarify for us in the problem that any interval is not going to start at like a negative value, so we can start at 0. So let's just start putting these intervals into our number line and see what happens. So we have 1, 3, so I'm going to have a line going from 1 to 3, which is over here. So this interval is length 2. We'll have an interval going from 8 to 10, another interval of length 2. We'll have an interval from 15 to 18, and the last interval is from 2 to 6. So notice this time we actually do have an overlapping interval, 2 to 6. So I'm going to draw it above. So I'm going to draw it where it's obvious that we have 2 intervals that are overlapping. Now, when you actually draw out the number line, it kind of becomes obvious that it would be very helpful for us to take these intervals and sort them based on the start value. We don't care so much about the end value because we want to go through our number line starting at the beginning, starting at the start value, going to the next start value, going to the next start value, and then continuing that, because this allows us to detect. So for example, we look at this interval first. We know it goes from 1 to 3. Next, we look at the second interval. It goes from 2 to 6. And since we just looked at the previous interval over here, we know that this one overlaps with this one. So what are we going to do? We're going to merge them together into a new interval. So it results in a new interval from 1 to 6, because remember, ultimately we are trying to merge the intervals. And then we go to our next starting position, which is 8. So we have an interval from 8 to 10, and we know it does not merge with this one because they're non-overlapping. We got some space over here, right? Lastly, we go to this interval, and it goes from 15 to 18. We know it does not overlap with this one. There's all this space in between, right? So just to reiterate, we're going to take our input list of intervals, sort by the start value of each interval, and then we're going to iterate through each start value, right? Starting at the first one, then the next one, then this one, then this one, and each time we're going to check, okay, does the current interval, does the most recent interval overlap with the previous interval? If it doesn't, we don't do anything. If it does, which it did
Dang, still pretty easy.
In this case, then we can merge them into one interval. Now, it might seem unnecessary to even have a picture like this because this interval problem is actually straightforward, right? We just sort and then we merge the intervals. But
Okay, back. Sorry, guys.
there are a lot more difficult interval problems where I'm telling you, drawing a picture like this, drawing a number line
helps.
to understand what's
It
actually
so
going
helps.
on makes the problem a lot easier to solve. So now let's
100%.
write the code. Remember, we are sorting the entire input, and then iterating through the input. So the time complexity is going to be big O n log n, where n is the number of intervals that we're given. So thankfully for us in Python, it's pretty straightforward to sort. We can just take interval
sort.
and what's the key we're sorting by? Because remember,
And
we're
log n.
sorting a list of pairs. So the key is going to be in Python, a lambda function. So in this case, I is going to stand for the interval. And what value of this interval are we going to use? We're going to use the first value. So at index 0, we're
Should I do one more Leetcode problem?
If we wanted to sort by the end value, this would be
I
of 1, but we're going to sort by
Maybe.
the start value only. And so let's also declare an output where we're going to put the merged intervals. So I'm not going to initialize this to empty. I'm actually going to take the first interval and have it inserted into the output just so I can avoid an edge case.
Yeah,
so
that's what I did.
We have initialized the interval. So
Very
now
nice.
we're going to iterate through every single interval in sorted order. And technically we can skip the first one because we already added the first interval into the output. And instead of just
Yo, the
having
fuck?
the interval itself, we know we're going to use
Okay,
the
no, that
start
makes
and
sense.
end value, so I'm just
That
going to
makes sense.
extract them like this.
That makes
And
sense.
so how do we know if the interval is overlapping with the most recent interval? Well, we can get from our output, this is why I added one, so we can avoid the edge case. From our output, we can get the most recently added interval and get the end value of it, because that's what we need to know if it overlaps. So the end value of the most recent interval, we'll call it last end. And we're going to check of the current interval we're at, the start and end value we're iterating through. If the start is less than or equal to the last ending value, that means they're overlapping. The equal is important because they told us in the second example that we are counting equal as overlapping. So if they are overlapping, what are we going to do? We're going to merge them. How do we merge them? Well, all we have to do is take the most recently added interval and take the ending value of it and set it to the max of itself, which we already have in last end, and the max of the current end value that we're at. And the reason we need to take the max is, what if we had two intervals starting at 1, 5, and the second interval is 2, 4? Because we would iterate through them in this order, because this has a starting value of 1, this has a starting value of 2, but notice how this actually has a larger end value than this one. So if we just take 4 and merge this together and set this to 4, we're actually making the interval smaller. We want to keep the 5 because merging these two together is going to actually result in 1, 5. So in the case that they're non-overlapping, what are we going to do? Well, we don't have to merge, but we do have to take that interval and still add it to our output. So we're going to take start end and just add it to our output. So what would be an example of that? Well, what if we had 7, 8? Right, these two intervals are non-overlapping, so the result would actually be itself, right? We don't have to make any changes. We don't have to merge. We can just leave it as it is. And that's actually it. So we didn't really have to do anything since we used the built-in sort. We took care of the main part of this problem, and all we have to do now is return the output. And so this is a pretty efficient solution. I hope this kind of explained a little bit of the intuition, and you kind of have like a visual picture of what is actually going on as we run this algorithm and why we're doing it the way we are. And I hope this was helpful. If you enjoyed, please leave a like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon.
Okay. Now, what is sweepline algorithm? The sweepline algorithm. Why does sweep line kind of look I don't know the word. I don't know what I'm thinking. Plane is an algorithm paradigm that uses a concept sweep line or sweep surface for various problems in Euclidean space is one of the critical techniques in computational geometry. I imagine that a line or from the vertical one is swept and move across the plane, stopping at some point. Geometric operations are restricted to geometric objects that either intersect or are at the immediate vicinity of the sweep line whenever it stops, and the complete solution is available once the line has passed over all objects. This approach may be traced to scanline algorithms of rendering and computer graphics. Generalized and extensions, references, okay, well. I mean, it's cool to know the term, except how do you implement it? One sec, guys. Okay. Alright. I don't need to look too deeply into it, but if I ever need to, I will come to it. This is really just an aside to the problem at hand. Regardless, this is another Leetcode problem solved. Non-overlapping intervals. This is another. Now we're going to talk about non-overlapping intervals. However, I think, guys, that maybe I will. Should I worry about it, or should I not? If I do worry about it, then it means maybe I can do it all these interval problems in 2 days. Maybe. Because I'm so close, right? I feel like I'm at a last stretch. Non-overlapping intervals. Why does this look good? This looks like, okay. Maybe I will do it. Alright, so given an array of intervals, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. The minimum number of intervals to make the rest of the intervals non-overlapping. Non-overlapping even if they are a common point, for example. 1 and 2 and 2 and 3 are non-overlapping. I see. After 1 and 4 is removed, the rest of the intervals are non-overlapping. 0 and 1. Okay. Now this is a little more different. But it is also just intervals. Is this a dynamic programming problem also? Does this use dynamic programming? Because you choose to have or not to have something? Overlaps. Like this doesn't overlap, but it's the first that does overlap that you just remove. But what if you have a situation where you remove 3 overlapping, and you could have instead removed 2 overlapping? You wouldn't know which one to pick unless you did some sort of decision tree, right? If you did a decision tree, you would be able to figure out the right combination to remove. So you might need a dynamic programming here to have or not to have. So if you think about bottom-up dynamic programming, say you had 1 and 4, right? The interval 1, 4. The max you remove is 0. Now you have 2, 4 and 1, 4. The max you remove is 1. Now you have, because they do overlap, the max is 1. Do you have to sort this as well? It would ideally be sorted as well. If you do sort this as well, then say you get 1, 2, 1, 4, and then 2, 4. You say from 2, 4, no overlaps. From 1, 4, 2, 4, there is an overlap between the ranges of 2, 4. So the choice is to either remove 2, 4 or to remove 1, 4. In which case, both scenarios return you both scenarios remove something. So remove one thing. So then that subproblem becomes 1. And then you look at 1 and 2 combined with 1 and 4 and 2 and 4. So 1 and 2, 1 and 4, 2 and 4. Maybe you see that 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 2 and 4. Maybe you see 1 and 2, 2 and 4 don't overlap. But if it does overlap with 1 and 4, it does. You remove. You remove? Would you remove anything? I don't think you take away the 1 and 2, 1 and 4. Trying to think. You don't take anything away. You don't take anything away. Or you don't add anything. Or you don't add the number lost. But if both of them overlap, then you know to remove that one, right? Is that right? You know to remove that one, particularly? Let me think. No, it'd still be 1, wouldn't it? If you remove that one... If it overlaps with 1 and 2, doesn't overlap with 2 and 4, but if it was 1 and 4 and 1 and 4. Say it was 0 and 2 and 1 and 5. Can you say that? No. Well, yeah, you can. Then it doesn't matter. But everything else still overlaps. Minimum to take away is 1. Get rid of the overlap. The taken up space now is 1 and 4. The 1, well, 2 and 4, and then the rest is, if you got 1 and 4, then it takes up 1 and 4 now. But you would remove one of them. One and 2 overlaps with 1 and 4. Would you overlap with the smallest? If it's the smallest, then you realize if it doesn't overlap, you don't add 1. But if it does overlap, you have to take another 1 away. Have to take another 1 away. Do you? Do you really? Let's think about this again. 1 and 4, no, 2 and 4. 1 and 4. And then 1 and 2. It was 1 and 3. Removing the 1 and 3 is still overlapping. Removing 1 and 2, 1 and 4, or 2 and 4. Remove 2 and 4, still overlapping. Remove 1 and 4, you're still overlapping. If you remove that one, you're still overlapping. So you have to do 2 at the minimum. If the minimum interval, you can't get it out, maybe, then that's when you increment. So if the minimum interval doesn't work out, then you have to increment. So the minimum interval overlaps with the current. So this is my thinking. Minimum interval overlaps with the current interval of interest. Then increment dp value for that current interval of interest. Okay, so that's my thinking on the problem. If they don't overlap, then no problem, right? You don't increment anything. That's the way I'm thinking about this problem. That's the way I'm thinking about solving this problem, except I have no idea if this is, I have no confidence in the fact that this is the right approach. Okay? But I feel like if I played around with multiple solutions or multiple cases, I might be able to even think about, I might be able to think about it. All right, let me get some water. I want to drink some water. I'm back. Except I need to go. DP has Burr taking a walk. You know what? You're not wrong. But yeah, I went to drink some water. Okay. My idea is an idea. It's an idea. Will it work? I don't know. Do I want to try this now? Or do I want to see the solution and be led on the right track regardless? I think I would rather the former. I mean the latter. So I want to see if I am doing the right thing. The fact that there is no solution here, it makes me sad. DFS, DP. Okay, you do use DP. Okay, good. Okay, good. Greedy sort by start. What the fuck? Sort by end. Okay. Cool. I'm just gonna say if we are using DP here, I might as well do it right now. Try and figure it out with my DP approach. If I can, then it'll be my first ever DP problem that I solve by myself. Technically. How are you enjoying that standing desks? Looking to get one as well. Well, I'll tell you for a fact right now, right? This, the one that I'm currently sitting on, isn't a standing desk. And it's very much solid. And it's actually pretty cramped. Yeah. But the one at home that I have, yeah, I love that one. I do love that one. I do stand. Actually, I want to stand more, right? I haven't been using it enough because I forget to. But with that said, in the office there is standing desks as well. Those are actually way more solid than my standing desk at home. The one that I spent $1,000 on, it's better than that. The ones in the office. The ones in the office, they're solid and sturdy. Like they don't move when you like move the table. Or when you lean on the table, they don't like actually look like they're about to fall. So it's making me rethink my choices of the specific brand. So I would say if you can, don't go for like up-down desks, what it's called in Australia. Those were the ones that were recommended on Reddit, but I don't know. Maybe I built it wrong. You know, maybe I didn't screw the screws tight enough. But yeah, I would say I would probably not want to buy an up-down desk again. Okay, with that said, let's try and figure this out. So, the minimum DP, minimum interval overlap. So minimum interval, we're gonna maybe go, we're gonna think, okay, each of these DPs are probably gonna have like, they're gonna probably look something like num to remove, right? And the start end, minimum start, minimum interval. All right, so this is what it kind of would look like. Now let's see. DP is equal to 0. Minimum interval, which is just going to be the very first interval. So intervals, we're going to say the very last interval. Yeah. Doesn't matter if you go from the start or the end. I don't think it matters. Except I will keep it bottom up in the sense that it'll go backwards to front rather than front to back. Doesn't make a difference. Just a habit now, I guess. Okay, but this is only for the first aspect. Would I care to know any previous ones? No. So I can keep it like a constant, like this. Perhaps. Holy shit, 1K and isn't sturdy. You make me regret the 101 that I bought on Amazon. Wait. Okay. $100 one that you bought on Amazon. Okay. Yeah, it might not be sturdy. But we'll see. Like, maybe it's a good choice. Maybe it's a good choice. You'll have to tell us. You'll have to tell us. Okay. For I in range of len of intervals -1, -1, -1. If what? If the interval of interest to the interval of interest let's see, if it overlaps if it overlaps. So the end. Okay, we also want to sort this, right? So intervals dot sort intervals 1. So this is the end is greater than the start of that, then it's overlapping. If it's overlapping, then your next DP is going to be the minimum of the two overlaps. It's just going to add 1, and then you take the min of the two overlaps. So this is the length, or like the length it takes up. If this length is less, is greater than interval I 1 minus interval I 0, then you would do this, else you just wouldn't do anything. You would return dp of 0. Well, oh yeah, just invalid syntax. There we go. Interval is not defined. Intervals, for sure. Well, let's have a look. Close, but not really. Your output was 0 when you expected a 1. Let's see the intervals. So print intervals. So I think the method that I had wasn't the right way. Use test case. The calf lead stack problem. I've basically forgot it now. I should revisit that actually. So it's actually a good idea at some point. Yeah. So after every change, we want to kind of check what this DP is. One, 1, 0, 3, 4, 2, 3, 1, 3. 1, 3. Ooh. 2, 3. Ooh. Yeah, obviously it doesn't overlap with 3, 4. But if it overlaps with 2, 3, but you're not looking for the 2, 3, then you have a problem, no? We also have to consider the 2, 3, so you kind of have to max. Do you have to max the 2 areas? Doesn't seem exactly right. Unless you do have to max the 2 areas. You say 1, 3. But it's not necessarily true either because they're separate. If they're separate, one, 2. You technically only need to remove 1 to get this working, which is 1, 3. But it's as if you don't really need to do that. Okay, if I change this to a greater than, equal to, it's still not going to work. DP1 is that. Yeah. By the way, when do I know when to use stack? Sometimes I have no idea whether I should use stack or not. Well, you should think of it in context of stacks or queues, right? Which of the two you should use? Which of those two you should use? The stack section, I do recall like a little bit. It's hard to say. But you should compare stacks with queues every time that you think you come across a stack problem. But yeah, how do you think about or identify whether it is a stack problem or not? Yeah, I don't know. I think that's something you'd have to consider. For me at least, I just look at the problems and I say, okay, if this is a stack problem, let me try and use a stack. If this is a dynamic programming problem, let me try and use a DP. Right, so I'm literally doing it by concept, knowing what the concept I'm about to learn is before doing the Leetcode problem. To be honest, when you mentioned Carfleet, I still didn't, remember the name and think stack straight away. So yeah, I can't even identify if it's stack or not. Okay. What the... Wait, why is this default to go? Well, this is interesting. As far as I know, I found that if the problems require me to store something in some order, I'd like to use stacks, or even like next greater, or next smaller elements. Like I would even say anything surrounding that could be stacks, queues, or priority queues. right? I would identify that as like a category, right? Of different, of these types of data structures. I forgot, I don't know the overarching term, but yeah, priority queues, and stacks. You know what I mean? Then yeah, it's just identifying whether to use any one of these threes makes sense, depending on, yeah, your problem that you're doing. Mm. Okay, let's say I look at this problem and
Hey
watch
everyone,
it.
welcome back, and let's write some more Leetcode today. So today let's solve the problem
I
non-overlapping
agree, Void.
intervals, and this is actually a problem from the blind 75 list of questions that we've been working on. And we've actually been tracking that list of questions on this spreadsheet. You can see that I do have a video solution on the left side over here for pretty much every single problem in this list, except for a couple that we haven't gotten to yet. So today we will be doing the last interval problem in this list. You can see I solved the other interval related problems already. There's about like 70 people viewing it right now, so I hope that you guys are finding it helpful. And you can see conveniently I made a YouTube playlist for all of the blind 75 solutions. Link to that will be in the description as well if you do want to take a look. So now let's continue with the video. So this problem is definitely like most interval problems in that if you've solved other interval problems before, this one shouldn't be too difficult, but if you're new to interval problems, this one is kind of challenging. So we're given an array of intervals where each interval has a start value and an end value. And we want to return the minimum number of intervals that we have to remove from the list to make sure that the rest of the intervals are non-overlapping. So first question you should ask is, what exactly is a overlapping interval? Well, assuming an interval looks something like this, right? It has some start value, maybe the start value is 1 and the end value is 2, right? Maybe we have another interval that starts at 3 and goes all the way to 4. So definitely these two intervals are not overlapping. But what if we had the interval starting over here? Maybe the end point is 3, but the starting point is maybe 1.5, right? Obviously, in this case, these two intervals are overlapping, right? You can see, right over here, this is the region that they're overlapping at. But the edge case comes when we have a interval, let's say, like this one, that's going maybe starting from 2 and going all the way to 3. Are these intervals overlapping? Technically, this point at position 2 is overlapping, but technically these intervals are not considered overlapping, right? So if they have the same edge point, they do not count as overlapping. This edge...
Hold on. No, never mind.
Case is very important to understand to solve this problem. Okay, so let's take a look at the first example actually. So you can see I've drawn a few of the intervals, and you can see so far these three are not overlapping, right? But we're about to insert the last and fourth interval, 1, 3. So it starts at 1 and goes all the way until 3. So now you can see that they are overlapping with the introduction of this interval. And things become really simple when you draw a picture, which is why I always recommend drawing a picture for complicated problems. So now we want to eliminate intervals. We want to eliminate the minimum number. It's obvious that we can just remove a single interval, this one that we just inserted, to make the rest non-overlapping. But of course, that's not the only way we could do it. We could instead remove this interval and remove this interval. So instead, we'd remove 2 intervals. That's clearly not the solution, but there are multiple ways to do it, which is why writing the algorithm for this problem can be kind of tricky. One definitely possible way to do this problem is brute force it, right? Go through every single combination, right? For every single interval, we can choose to remove this interval or to keep this interval. And if we have 2 choices for every single interval inside the list of intervals, then, the time
decision
complexity
tree.
to check every single possibility
2 to the n.
2 times 2 times 2, basically 2 to the power of n, where n is the size of the input. So that's obviously not very efficient, but can we do better? And we definitely can, and it takes a greedy approach to solve this problem. When we're actually given this list of intervals, the ordering of them could be pretty random, right? But what you can see when we actually draw the picture, why would we want to go through these intervals in a random order? Why would we want to look at this one, then look at this one, then this one, yeah, right? Like in just a completely random order. when you look at it this way, it kind of makes sense to want to go left to right, right? To see, okay, here are they overlapping, here are they overlapping, etc., etc. And the easiest way to do that is to iterate through them in some kind of sorted order. You can probably do it sorted by the starting point or sorted by the ending point. I'm just going to stick with sorted by the starting point just because it's a little bit simpler for me, but I know that it works in both ways, for this problem at least. So when we iterate through these in sorted order, first we're going to compare these two intervals, right? We want to compare adjacent pairs of intervals, right? And let's actually ignore this example for just a second. Suppose we had just two intervals, right? One interval like this and one interval like this. Okay, they're in sorted order, right? And we're comparing adjacent pairs. So we're going to look at this one and look at this one. How do we know if they are overlapping? Well, if they're sorted by the starting point, we know that either they both have the exact same starting point or the second one has a starting point that's after the first one's starting point, and that's the case here. But again, how do we know if they're overlapping or not? Well, the easiest way to check is they're not overlapping if this one starts after this one ends, right? If the second one starts after the first one ends, then they're definitely not overlapping. But on the other hand, if the second one starts before the first one ends, then they're definitely overlapping, right? You can see that this is the point that they're overlapping at. Okay, so does that cover all of the cases? Well, there's one more case. Technically, that's slightly different. What if, the first one is really long and the second one starts here, right? So it does come after this one, but it ends before the first one ends. This is a slightly different edge case. Again, they are overlapping. We can detect that with the same condition. This one starts before this one ends. So yes, they're overlapping. But now, suppose we had a third interval that comes next. Remember, we are traversing these in sorted order. So first we're going to compare this one is first, this one is second. So then we're going to compare these two together. Next, are we going to be looking at this one and this one? In this case, yes, because remember, if these two are overlapping, we don't have to remove both of them. We only have to remove one of them. So the choice is, are we going to remove this one or are we going to remove this one? Well, which one do you think we would rather remove? Would we want to remove the one that ends first or the one that ends second? Of course, we'd want to remove the one that ends first because then there's less of a chance that it's going to overlap with the following interval.
Hold on. You remove the one that ends first. Why? Because it has less of a chance to interact with the second? Wouldn't it have more of a chance? No. Oh, you remove the smaller one, but that's the one with the less of a chance. Let me read that again. Let me listen to that again.
Remove this one. Well, which one do you think we would rather remove? Would we want to remove the one that ends first or the one that ends second? Of course, we'd want to remove the one that ends first because then there's less of a chance that it's going to overlap with the following intervals that come after. And remember, we want to minimize the number of intervals that we have to delete.
So you minimize the number of intervals you have to delete by maximizing the input, right?
In this example, with these three intervals, it doesn't matter. We could remove this one or remove this one. But let's look at another example. What if the third interval was like this, right? It's overlapping with this one. Then it becomes pretty obvious. We would want to remove this bottom interval rather than this top interval.
Yes.
And it depends on which one of these ends first. So that's how we're...
Oh, I'm still not getting it. Wait. So you're still removing the one... Wait, what the fuck? Okay.
We're going to decide which one to remove. And just to look at a third example, so what if they were overlapping like this, right? Of course, we're going to first compare these two intervals. Okay, yes, they're overlapping, and we can detect that because this one starts before this one ends. So now we have a choice. Do we remove this one or do we remove this one? Again, we're removing the one that ends first. So we're going to remove this one, and you can see...
We're removing the one that ends first. What the fuck are you talking about when you're removing the one that's not ending first?
Exactly why? Because now these two do not overlap.
Bro, the wording that he's using is not clear. Let me see that again.
And this one starts before this one ends. So yes, they're overlapping, but now suppose we had a third interval that comes next. Remember, we are traversing these in sorted order. So first we're going to compare this one is first, this one is second. So then we're going to compare these two together. Next, are we going to be looking at this one and this one? In this case, yes, because remember, if these two are overlapping, we don't have to remove both of them. We only have to remove one of them. So the choice is, are we going to remove this one or are we going to remove this one? Well, which one do you think we would rather remove? Would we want to remove the one that ends first or the one that ends second? Of course, we'd want to remove the one that ends first because then there's less of a chance that it's going to overlap with the following intervals that come after. And remember, we want to minimize the number of intervals that we have to delete. In this example with these three intervals, it doesn't matter. We could remove this one or remove this one. But let's look at another example. What if the third interval was like this, right? It's overlapping with this one. Then it becomes pretty obvious. We would want to remove this bottom interval rather than this top interval. And it depends on which one of these ends first. So that's how we're going to decide which one to remove. And just to look at a third example, so what if they were overlapping like this? Right? Of course, we're going to first compare these two intervals. Okay, yes, they're overlapping, and we can detect that because this one starts before this one ends. So now we have a choice. Do we remove this one or do we remove this one? Again, we're removing.
Remove the one that ends second. He means remove the one that ends second. I'm pretty sure.
The one that ends first. So we're going to remove this one, and you can see exactly why, because now these two do.
Remove the one that ends first. Remove the one that ends second. I think that's
not overlap. But what if instead we decided to remove this one? Well, we removed it, but it didn't help us because these two are still overlapping. We want to minimize that. So basically, I just explained to you the exact algorithm that we're going to be using. We're going to sort the entire array based on the starting value. Then we're going to compare adjacent pairs and then use the conditions that I just mentioned. Now, what's the time complexity of this? Well, we're going to sort, and then we're just going to iterate through the array a single pass, right? So the
sort and then iterate through the array in a single pass.
Is simple. It's just big O of n. We're just going to iterate through the entire array. But the sorting is where the bottleneck is. So that's what the overall time complexity is going to be, big O log n log n. And just to run.
But this is why it's greedy, isn't it?
The algorithm that I explained on this input example, because they have the first two starting values. So we're going to have this array in sorted order based on the start values. We're actually going to take the first interval and just take its end value and then keep track of it. Because since this is the first interval, there's nothing going to be that comes before it on the left. Okay, so now we're going to iterate through the intervals that come after this one. So the first interval is this one. It has the next start value. So we're going to check, is the start value less than this one's? Yes, they are, so they're overlapping. So which one are we going to delete? The one with the larger end value. So we're going to delete this one. We can leave this interval as is and save its end value so that we can compare it with the following intervals. So this is the interval that comes next. Is its start value less than the end value of the previous one? No, it's not. So we don't delete either of these intervals. But since we didn't delete either of these intervals, and since we know this one started after this one ended, we know that this one is going to have a larger end value. So we're not going to be using this one to compare anymore. We're going to be using this end value to compare to the following intervals on the right side. Okay, so now let's look at this interval. And the next interval that's coming up is this one. So is this one starting?
Right, that would make sense why sorting helps so much.
So we don't delete either of these, and we set this to the new end value that we're going to keep track of, but there's nothing that comes after it, so we're done here. We only had to remove one interval, as you can see. So the answer in this case is 1, which is what they also had in the output. So that's the entire algorithm. Now we can actually code it up. It's not too bad.
Okay. So look, he describes a greedy approach, which is also not dynamic programming. The dynamic programming that I was thinking of isn't talked about in this video, unfortunately. Which makes sense, because this is meant to be a intervals problem, which is ideally going to be a greedy solution. I guess. I'm just trying to think. Okay. The recursive solution is 2 of n with space complexity of n. Yeah, I can see that. And then dynamic programming top down, where you use a memoize. Where you memoize. And when you memoize, if I in and why I. Yeah, okay. In this. Memo I res n squared n. You can n squared this again. Zero to the n. Ij dp of I, dp of 0 is equal to 1. N minus max non-overlapping. Non-overlapping, I see. So I see non-overlapping versus overlapping. So non-overlapping stuff that haven't been overlapped. For j in range, intervals ji, j1 less than equal to. So the end less than equal to that, then well, that's an overlap, right? So it's either to include j always greater. Yeah, j is always greater. Start at least. Oh, whoa, the end. You're using the end. Intervals. That's interesting. I wouldn't have considered any of that. Sort by start and sort by end. This is a cooked question. You're going to come back to this tomorrow. Okay, but I can see how it was partially dynamic programming.
Okay, so now let's get into everybody's favorite part, writing out the code. So remember, the first thing we want to do is sort the list of intervals. So in Python, I can just say sort, and it'll actually sort it based on the entire pair. It'll first sort it based on the start value and then sort it based on the end value if they're.
So look, let's try and go through Leetcode solution. We'll restart this. The idea is, yeah. So intervals dot sort. What do we have? We have result. and end, start and end, start. I'm blanking. I've almost depleted all my Leetcode energy. I should eat soon, actually. Oh man. 3 Leetcode problems, taking the rest of the day. Taking up to 4 hours now. Almost. What do we think? What do we think here? What do we think? We could, that first value. Only consider the end value. I think that's right. Ooh. Ooh, I failed on a test case. This is a pretty weird test case to fail on. Alright, let's have a look at the solution.
We get to our if-else case because we want to know, are they overlapping or not? So they're not overlapping if the start value of the interval that we're looking at is greater than or equal to the previous end value. And remember, the
Okay.
Is very important. That's the edge case we talked about at the beginning. If they're equal, they're technically not overlapping. And if they are not overlapping, the only thing we need to do is update our previous end, set it to the new end value, because we know that the new end value is going to be greater than the previous one. And the else case is if they are actually overlapping. And if they are overlapping, then we need to remove one of the intervals. So definitely we are going to increment our result count by 1 because we have to remove one of these. Now the question is, which one are we going to remove and how are we actually even going to handle that? Well, the only thing we actually need to update is our previous end, because remember, we don't actually have to delete the interval in the array. We just have to count how many we delete. But we do have to update the previous end. Remember, which one of these end values are we actually going to keep? Which one of the
The second one. Ooh. What? Perhaps. Nope. Okay. Let me go back to this.
Hey everyone, welcome is going to be greater than, because remember, we don't actually have to delete the interval in the
Hello,
array.
Zahib.
We just
Welcome
have to
in.
count how many we delete. But we do have
I'm
to
doing
update
great.
the previous end. Remember, which one of these end values are we actually going to keep? Which one of the intervals are we going to keep? We are going to keep the one that has the minimum end value. So we're going to set previous end equal to the minimum of end and itself previous end. So that once we've
So it's a min.
updated this, we can use this new end value in the future iterations of the loop. But that's actually the entire algorithm. Once we've done that, we just have to return the count of how many we deleted and then run the code and make sure that it works. And as you can see, yes, it does work and it is pretty efficient. So I really hope that this was helpful. If it was, please like and subscribe. It really supports the channel a lot.
Interesting. So it was the min and not the max. Current max. If current max. If intervals 0 greater than current max, then you know for a fact that you don't need this. And you can just get it. How's your Amazon intern going? Internship going? Yes, it's going good. There are things. I'm a third of the way done. There are things that I need to do now and work actively on to better my chances of a return offer. So there are things that I'm still hustling with as well. Actually, I don't like the word hustling anymore. I should stop using it. Okay. Regardless. Good question. How's your Amazon? Okay, so remote? No, it's not remote. I'm literally working in person 5 days a week. Most of the time. Four through five. Wait. Okay. Thank you, Zahib. Vim looks complicated, but I've seen people use it so effectively I might try to learn it. Yeah. I'd say, if you have the time to do it. It'll be cool to learn. Nice to think about. Okay, I see. Get all. Hmm. Hmm. Alright, there we go. That's done. Get pull rebase is what I needed. Solved. Okay. Okay, done. We're gonna be done now. We are done now. I don't want to do any more. I want to now chill before I continue with some other fun for myself. The one aspect of this though is that let's see, to-do list. Leetcode, basically done. We're gonna probably not do workouts. We're gonna have dinner now. We're gonna have to do that. We're gonna have to figure that out. Okay. Shit, it's already late after. Okay, I'm gonna make this tomorrow, first thing in the morning. Read over. Okay, so yes. These two things are very iffy to do, but they're going to be there for a while. They're going to be on my mind for a while, so I'm going to keep it there. And I'll do this offline because this is kind of personal. Or I should not call it personal, but it's like a work-related problem. Okay. Cool. Thank you guys for staying along. And I'll catch you guys in another one. Peace.